space missions, designs, and operations. For this, I would like to invite Ms. Aya Iwamoto to join us on the stage for the keynote address.
Good afternoon, everyone. Thank you for the kind introduction, and it's very difficult session right after the lunch that everyone gets full and everyone gets sleepy. And apology that I try to bring some images for you for my keynote speeches, but I don't have a pen drive, so please bear with me only speaking. I try to be communicative as possible. So my name is Aya Iwamoto. I'm from Astroscale, Japan. Astroscale is a company headquartered in Japan. We have headquartered in Tokyo and 4 offices around the world, UK, France, and US. And I do belong a Japanese subsidiary company based in Tokyo. So let me start with my keynote speech. As we have already talked, as we have heard in the previous sessions in the morning and yesterday, I think, we all recognize that space systems are deeply woven into our daily lives, from communication, navigation, weather forecasting, disaster management and response, and even national security these days. And the importance of space assets are only growing. And as our reliance on space increases, so too does the congestion in orbit. Number of objects in LEO has grown dramatically due to the emergence of mega constellation of communication or remote sensing satellites. And a number of close approaches between space objects, so-called conjunctions, is reported to has become nearly triple since 2020. And these near misses increases the risk of collision, which could create more debris and threaten the safety of operation. So space safety and sustainability of the use of orbit is no longer be taken for granted, I would say. But at the same time, access to the space, the expansion of access to space itself is a welcoming thing. I think in today's morning keynote session, Professor Kaiwei Schrogel talked about that it's very important for us to create a level playing field for everyone who would like to use a space and exploration. That is exactly true, and I think access to space is expanding both for traditional actors as well as new emerging players like commercial sectors and even developing countries. So we need to, the question and challenge is, how do we preserve the long-term sustainability of space without limiting the future access to space, even to those who are not enter into the space activities now. So to meet these challenges, I think we need to rethink how we operate in space. Please imagine or think about the industry on the ground. I know that you're all from space industry, but as automobile industry, aviation industry, maritime industry, for maybe like taking up one example of automobile, it starts from R&D, manufacturing, and people sells the car to customers, and operations will start, and post-servicing. If your car get broken, you will take it to repairs, or if your car is running out of gasoline, you will go to the gas stations. So there's a full cycle or full value chain of starting from R&D and post-servicing on the industry on the ground. But on the other hand, in the space, there is no such a thing as post-servicing. Come to think of it, once the satellite is launched into the orbit, you can do anything about it, maybe without International Space Station. So post-servicing as repairing, refueling, or refurbishment, or removal, or upgrade is not exist in the space industry. So satellites are designed and manufactured and operated for a single use only. And most of the cases, many of the satellites are left in the orbit for like 20 years, sometimes even more, 20 years after the termination of the mission itself. So we think there is where on-orbit servicing comes in um, as a key solution for satellite operation, providing services that could extend your life of satellites or refuel your satellites, repair satellites, or remove your satellites in case it's defuncted to create a space for your satellite or some others in the orbit. And you may think that we are talking science and the fiction, but the core technology for them is called rendezvous and proximity operations, and this technology used to be only developed among the major space agencies related to the International Space Stations, but private companies are working on developing these RPO technology, mostly collaborating with the space agencies now. And my company, Astroscale Japan, recently has successfully made a close approaches to the actual space debris, that is H2A upper rocket body, launched in 2009. It's 4 meter, no, not the 4 meter, 4 you can imagine the 2-decker bus on the street. That's probably exact the same size of the H2A rocket body and debris. And our servicer satellites, Address-J satellites, successfully made a close approaches to the this actual debris by 50 meters and made a fly around, and even made approaches to 15 meters. And the video, that's the video I really wanted to show it to you today, but if you Google Astroscale and Address-J, maybe fly around, you can check out these videos taken from a servicer to the actual space debris. It's actually beautiful. And so we have successfully conducted RPO, close approaches to H2A upper rocket body, and we are now working on developing a satellite to remove this H2A rocket body, expected to launch in 2028 sometime, to bring the H2A rocket body to the lower orbit, lower enough so that it will enter into the Earth much sooner than 25 years. So looking ahead, we are planning to expand services from active debris removal to refueling satellite, maybe in the GEO, and try to expand services from both LEO and GEO. That's we are planning, and our engineers are working on developing technology with the fund provided by the Japanese government. We are currently have 3 projects ongoing. One project is called ISSA-J1. The servicer satellite is trying to make a 2 close approaches to 2 separate different satellite and objects in one mission. And satellite usually have very distinct feature. Each satellite has different features. So when we compare with the upper stage rocket body, the figure of the satellite is very complicated. So that makes the close approaches even more difficult. So that's a challenge. We are trying to make a close approaches to the satellite and to try to do 2 close approaches by 1 servicing satellites. And we are also planning to conduct this Address-J2 satellite mission, which I mentioned, to remove the H2A rocket body. And the 3rd mission is refueling mission in the GEO. And then we also got contract by Ministry of Defense by Japan to develop our GEO satellite system with RPO capabilities. So looking ahead, we are planning to expand our services. And with this new technology, our message is we need to create a value proposition for on-orbit servicing that could change the behavior on the satellite operators so that we can preserve the orbit sustainably for future and current and the future use for all of the actors. Thank you. That's my presentation. Thank you for listening.
I would request you to join us on the dais. For this session, Sustainable Space Mission, Designs and Operations, I would like to invite our esteemed panelists on the dais chair and moderator for this session is Mr. Sudheer Kumar, former director, CBPO, ISRO. Mr. Tushar Jadhav, CEO, Manastu Space. Mr. Sakthi Kumar, CEO, Orbitaid. Mr. Vineel J, founder, Taramandal. Mr. Amer Sayegh, Assistant Director, Journal, MBRSC. Now, I would like to hand over the mic to the chair of the session.
Thank you. Probably after a good lunch, hope that people should not sleep. The responsibility lies with the panelists, how best we keep the audience awake. Probably that after lunch, that would be another challenge for the panelists. Hope that we have a very good, we are going to have a good session, productive and fruitful discussions. Especially the sustainability is when we create a mess in the space, and how to clean the mess is also another business. Okay, creating mess, probably in a lighter sense, I am putting it up, even though it creates lots of business value to the many companies. But that mess creation and mitigation of the risk, that is what we are seeing. If we see the fundamental factors of the evolution, space evolution, fine. People are getting better services in terms of communication, in terms of, but actually why the sustainability is coming into picture is basically the self-created problem. And more problem is with the rogue nations. When they try to create some kind of disturbance, that is more, because as long as everybody are disciplined, unfortunately, probably when UN conventions were conceived, this space traffic management, space situational awareness would have not been the subject at that time, because after geopolitical issues when come, inserting new clauses would obviously is not a very easy task. Even though India, thankfully, last year we have organized a 42nd inter-agency space coordination, interagency debris coordination committee which we have deliberated. India is very active. I think today evening you are going to listen to Dr. Anil Kumar, who is the Director Track and is Vice President IAC, and he is the Debris Coordination Committee Chairman. I think quite interesting talk. I request all of you to attend that talk. Should be quite interesting. So ISRO has committed for debris free space missions. So the recent Exposat mission, if you say the POEM, which is again an R&D platform, temporary R&D platform for many startups, we have successfully brought it down, because that's what morning somebody was making, a director ISPL, he was making a statement that before the convention comes, India has committed to self-create or self-impose the policies to bring back the debris into the earth. Today, if you see, around 42,000 useful debris, manageable, more than 10 centimeters are there. But not very many countries have got a provision to track these debris, because every country is now putting the satellites into the orbit. Geo, very difficult to approach, even though it gives high throughput geo satellites systems. LEO is getting congested, because slowly Starlinks you are seeing, what is the roadmap, next generation, then OneWeb, then Keeper, then Gowang, yes, China is also beating. By the time when we see the McKinsey report, some time back I was reading through, the objects, the tentative numbers they are storing, 72,000, 40,000 satellites. One way, the small satellites, next gen satellites, when you see, they are becoming bigger in sizes. Maybe even though they start with 70 kg or 80 kg, that's what we have done, ISRO has done OneWeb. The next gen, when you say, little bit increase in the size. When the increase in the size is there, definitely it requires more orbital control and the collision avoiding mechanisms, tracking, cataloging, monitoring, ground-based systems, space-based systems. So these are all one of the, let us say, important episode of the sustainability is traffic management. You should not become another Bangalore in space. So ultimately, where we are going without even signals, without even GPS there, where the things are going, it should not become. That is one concern. Then the debris, and passive debris, which is spent stages. The spent stages could be avoided only using the reusable technologies. See how many rocket manufacturing companies have got the reusable technology is a question mark. You see Electron, I think rocket labs, I think after 50th or 40th only they are attempting how actually they can bring back, they can use the, because reusability is not the so easy task, where it is going to be fallen, how to recover, because what are the costs that are involved, because when we have seen to get back our crew module from recovery, are bapre, how much one Dornier has to go, sub is there, he will tell you, one ship has to go, one coast guard has to go. It is not a simple mechanism to recover the stages, even though people say very easily the reusable rockets. And especially for missions, the falling points is another important thing. So if it is a heavy mission, the falling point is, let us say, 5,000 kilometers, 2,000 kilometers away from your landmass. How to bring that one? That is where probably I think morning Australian session was there. Australia could be a better choice when we see the eastward launches somewhere near Indonesia or beyond Indonesia and Nepal. We can get back. So international policies, such things have to come. When an Indian object goes there, how to get back, how the entire MTCR or TAL, any policy changes internationally have to be done. That is another thing. The debris reusability, debris management, reusability. In space fueling, what Sakthi is going to talk about, that should be the ideal thing, how actually we can reduce our traffic so that the life of each and every satellite can increase. That is another mechanism. The debris cleaning, Astroscale, I am very happy to see JAXA and Astroscale joint research using the lasers. When you fire the laser, if somehow create a thrust against the satellite movement, that's how when the velocity comes down, it will come down to the atmosphere, and they themselves they will mitigate in the atmosphere. That is another important thing, activity laser, how actually lasers can be used. Pardon? Okay, okay. So these are all the technologies that are coming, how to bring back the debris. Fine, other technologies are there, artificial intelligence technologies and other things, because today it has become 24/7 for the scientists to monitor where the satellite movements are there, how to avoid, if at all any collision is likely to take place, how to maneuver, how to apply the techniques. If on board, let us say artificial intelligence, some kind of techniques are there, autonomous way the satellites can mitigate and can take left and right, how to that. So these are all the new technologies that we have to talk about, and many startups, thank God that they are all into this new kind of innovations, how actually even for laser tracking today, unless otherwise there is an instrument. Forget about the old satellites, the new satellites, definitely we can incorporate those technologies. The headache is the dead debris which are not cataloged. There is another problem. The old satellite debris, satellite active and non-active, where such kind of technological provisions are not there, how actually bring back, or rather put back the necessary technologies to track and mitigate. So these are all the challenges for the sustainability. Probably the international community is addressing in the policy point of view. The international different startups and different national space agencies are very seriously working, and India, like committed nations, are already implemented the zero debris mitigation plans in the recent launches. Hope that people are there who are very good, and unforgettable. Important thing is green propulsion. How we will not spoil the let's say if you are using N2O4 and UH25 let's say paragolic propellants in the final stages, which is still there, PS4 is still there with the propellant. If at all any remnant propellant is there, in case if it collides, and if that dangerous propellant leaks out, how we are spoiling the space also, not only the earth. So that is green propellant have to come in. Now today the technology nicely, Tushar and some of the companies they have developed and they have proven the technology prowess, but actually how to rate, how we can create today's satellite thrusters we are using, but how these green propellants can become a potential propellant for propelling the rocket stages. That is very important concern. So these are all the concerns I am just putting across to the panel, where some of them should address these plans in there. Probably I think we have time up to 2:37, maybe 3:15. So 3:10, we'll cut short 5 minutes. We'll give the advantage to the panel participants to put questions. I request from Amer probably to give your perspective and what is your this thing. Leave me last 10 minutes for one round of questions. What I wish to listen through your mouth. We can start, please.
Thank you for the introduction and as you said, it's a very hot topic for everyone around the globe, but not everyone is taking it with the same, let's say, seriousness. I think this is the major issue that we have. If you are a satellite developer, you have a little amount of space from engineering side to account for your return or your return to Earth and so on. You would focus more on the operation of your satellite, the cost of launching it and operating it. Eventually you want to use the maximum available mass or engineering capability to focus on the payloads, on the application. The last thing is you want to think about is after 6 years or after 15 years, what will I do with the satellite? So it starts from there, and then when it comes to regulating this topic, nations have a big division. Who caused the initial congestion that we have? Let them pay. I am a newcomer. I will not focus on this. So you have a lot of political and let's say economical conflicts between everyone on this topic. In the UAE, we're a latecomer, but we're trying to be a responsible latecomer. So in the UAE, we started back in 2006, and we started developing our satellites and launching them. And in 2015, the UAE Space Agency was established, and the agency focused on the law, space law, and regulations. And one of the main pillars of our regulations is sustainability and how to enforce by law any entity that is developing satellite in the UAE to put into account the sustainability measures, whether it's putting a propulsion system or material used in the satellites or the systems, and also monitoring the space systems even after the end of life and how to return them to Earth. All this is done in accordance with the UN treaties, but also with an advancement and adherence to latest technology, let's say. In MBRSC, we've been focused on developing our satellite system and capability. We try to do that as much as possible in our country, but you cannot do space systems alone now. You have to work globally, and that's what makes it successful, actually, I think. In the UAE, we never did something or any project just in the UAE. It doesn't make sense, We try to always look for partners, either on a, let's say, a sector level. So I will use a launcher from another entity, or a ground system from another company or a country, or on a smaller component. So you don't need to develop all the systems. And actually, this is one of the main reasons why we are here. We would like to see how we can approach the industry here in India, how we can really cooperate and collaborate in building new systems with these, of course. One of the main pillars is, let's say, can you give me a system that makes it sustainable and so on. In terms of sustainability itself, we've been investing in propulsion systems. So we have used chemical propulsion systems, and now we have also invested in electrical propulsion systems. We'd like to develop these technologies to help our systems and the global entities around the world to build technologies that will enable us. And electrical propulsion is, it's not a big thrust or force, but it's light in mass and in weight, and it's quite reasonable for the size of satellites that we want to develop. And this helps us. We did an investment earlier with Japan back in 2012, and recently we have launched a satellite which uses another new technology in propulsion with a company called Steamjet in the UK, and they use water as the fuel for the propulsion. So this kind of research is something we're trying to focus on and fund. And the next one we will launch is, it's not a propulsion company, but a company that provides a system to deploy a parachute to slow down the satellite system and then bring it to Earth atmosphere. So we're continuously investing in new technologies. The traditional technology of propulsion and so on, it's helpful, it's exhausted, and sometimes it's too heavy to hold or too complicated to adapt. We're trying to support companies with new innovative ideas, and we launch them with our satellites and see how we can adapt to that. I will not take more. I think I wanted just to introduce MBRSC and what we do in the UAE, both from a regulation perspective and also from technology perspective, and we continue to support this research. And again, I would like to shout out to all the companies here, economy here, and in the space industry in India, that we'd like to cooperate with you guys, and we look at that as a major opportunity. Thank you.
Thank you. Thank you. I'll go to Vineel. I think Vineel, you are doing a great job in the starting front, I should say. A couple of times I discussed with your professor online, and we have been discussing your perspective. Let us say, what is your vision, or how you go about, what are the impediments right now you are facing in terms of your role in space manufacturing, what are the targets that you keep?
Yes.
Can you throw some light?
Yes. So first of all, I thank you for this opportunity, both SIA-INDIA and also Sudheer for this opportunity. So this is Vineel from Taramandal. When I built Taramandal, I had this conviction that the space should be more sustainable and also a shared resource, but not a dumping yard, right? So that is where, when I talk about things in space, more and more orbital congestion is being happening, and also debris is being rotated around the globe. That is where it might be a threat to future sustainable space activities, and also it might be a threat to commercial space activities as well. We believe that we should redesign, rethink all the operations we want to do in space, and reduce the short-term design thinking, and also focus on more on long-term design thinking of satellites and also other space assets which we want to launch into the orbit. At Taramandal, we are trying to build heat shields and also re-entry systems, which are very much unique in nature, which are very much light as a fabric-like material, and this will help your satellite to not only enter into the Earth's atmosphere but also land on Earth, acting as a decelerator as well. So when I talk about reusability of satellite, this also will open up a new domain of in-space manufacturing and also microgravity experiments, and these heat shields will be topped onto satellites, making your satellites also reusable as well. So these are the systems we are trying to work on, and also actuation systems which will be as components which will help you in the landing gear and also in the launch and the landing as well.
Vineel, I'll come back to you because specific questions I have with you. Go to Sakthi. He is going to operate India in-space petrol pump. Taxi and petrol pump is quite interesting and innovative. Throw some light on that one, Sakthi. Where you are come, we need your services as early as possible.
Thank you, sir. It is always happy to be part of your panelists. Whenever I'm with Sudheer sir panel, I always get energy. And thank you so much for organizers. And so yeah, we are founded that startup. We founded this Orbitaid in that mindset of sustainability. We started with the sustainability thinking actually. So when we have started that sustainability thinking, actually where that there is no standardization, there is no things is there, but already the space is actually flooded with debris. So we have to identify that how to extend that life of the satellite. For existing satellites also, there is a projection, and you can also, you also mentioned about that there is a projection for the Starlink and OneWeb and other things as also, where already there's a sustainability thought is put it out in the world or globally, but there is not accommodation in the standardization or interfaces adoption or any other modular design and all those things. So we actually come up with a solution. So how to identify that existing satellite and take care of that, that is make that satellite into sustainable. So for existing satellite, we come up with a strategy. Actually, we can extend the life of the satellite with this actually life extension pod. So basically, instead of refueling it, we can identify that where that standard port is there with a LOR ring, and we can do that we can dock it and extend the life of the satellite, and we can bring that debris also. So that is for existing satellite. We actually come up with the solution. For upcoming satellites, we have our own patented docking and refueling interfaces, which is actually a SIDRP. It can be go for all the satellites, upcoming satellites. So it is not only do the refueling, it can do the power transfer and data transfer as well, and it can be used for debris removal plates. Where that we are facing that some problem, so and not we are facing that ISAM communities. That ISAM communities, actually there's a lots of innovation coming in the ISAM communities, but there's a communication lag or the communication lag between is an ISAM innovator and the traditional satellite manufacturers. The satellite manufacturer has to be accommodate that standardization so that the upcoming satellites can be more sustainable and bring it more and more. And that is what so. But this actually sustainable and life extension, refueling, this actually new market. How we have to make that sustainable, how we have to make that reliable, repeatable, that is important. How this market has to be matured, that is important. So for that, actually, we have done that ground test, and we slowly moving to that, we done that couple of times as zero-G test, microgravity test. The microgravity test, that is actually short-term space station kind of things. We actually identify that first time when we done that, we identified that lots of bubble formation. The bubble formation is actually very crucial for the crucial part for that refueling. So if that bubble formation is there, then it is not matured that technologies. And satellite operators, satellite communication providers, nobody ready to buy that one. So technically we have to mature that one. So how we have to do that? So we done that second time, we achieved that bubble separation, other sloshing activities, and when we do the refueling, and that refueling should not affect that other customer satellites or tanker satellite and RPO things. That is, we achieved that second one. And the first time in India, so we are doing that demonstration in space in another 2 or 3 months in the refueling from one tank to other tank. That is how we are maturing that market and making the sustainable, so that all satellite operator, all customers, all telecommunication providers by that point and go for, they are waiting for the sustainable, but they are also looking for the technical maturity. That is Orbitaid company.
Oh, a supplementary question, let us say when you are talking about the fueling, what are the associate technologies? Like whenever you go for a traffic congestion, police person will take a truck and put all the scooters there in a crane and putting it. Like that, do you have any docking mechanism or OTVs, or what are the associated technologies? First is good that you said that old things you are collecting. And from a main petrol pump to the, to the vehicles, what kind of arrangement, technologies that you require?
Yes, sir. Actually, we come up with a tanker satellite solution. So the tanker satellites has two different things. That tanker satellite can do the refueling, and the tanker satellite can do that docking and other things. It will bring back to our petrol pump actually. So it is a mother satellite will be there, and the baby satellite go and get it back to the things. So it is not only that docking and the refueling interfaces, other robotic arms for that on-orbit servicing, and there is an important thing is, okay, so we can do the refueling, but efficient and the refuelable propellant or refuelable fluid immediately go for maneuvering. So the maneuvering actually immediately the propellant settlement has to happen. So we come up with a solution for refuelable propulsion system. So immediately we can do the refueling, and immediately that customer can do that maneuvering. So that is how that we come up with. And another one is RPO sensor suite. That is a accessories part. So that is important. So already Astroscale is actually done that, but from India we are also bringing it. It will be good for the collaboration.
No, no, good, good. That is a good thing. Now petrol pump is over. Who will fill the petrol? Probably Tushar has to
Thank you,
throw
sir.
some light more on the green propellant. You are doing other technologies also. What is the qualification of the green propellant? How actually the aspects or challenges that are there to scale it up? Can you throw some light, Tushar?
Yes. Thank you, sir. Thank you so much, SIA. So we're talking about so we have Manastu space and we're building green propulsion systems for satellites. Uh, the sir mentioned value chain in terms of the challenges in terms of sustainability. I will take one more step back and the challenge in terms of sustainability in terms of ground. So when the current fuel that sir was mentioning, the hydrazine, UDMH, all those fuel that has been used are extremely toxic. That as toxic as cyanide and carcinogenic also. So if you inhale it, if it falls on your body, the chances of getting cancer or death becomes very highly. And people have died handling it last 40, 50 years. But then it has been used because it works nicely. The people know how it works. So the sustainability for us starts from that end. What happens on the ground, not just on the space. So starting from here, and then if you see the launch vehicles, so many of the time, especially if they're solid, you will see a lot of percolate. When it combusts, you will see a lot of deposits around it, the powders after the combustion. So how do we ensure that the whole value chain becomes sustainable so that we don't create one more mess in the space as we are already on the verge of it? So for that we are answering the starting problem of it, something that is much easy to handle in terms of toxicity, much lower cost, because unless the cost you don't match it or even reduce it, people will not be able to, there's no motivation to accept, and something that is at least some, if not higher, the same performance, because given that you have the same maturity, same reliability. So as sir mentioned, what are the challenges we have faced in the journey? Of course, getting the whole system right in terms of the fuel, the engines, the whole line items of it, like the solenoid valves and all of it. Because for most of the satellite, the propulsion system fails, satellite fails. So it is as that critical, because you are at particular altitude. With a drag, you start losing the altitude, and for say Earth observation images, you need to be in the particular orbit. If you don't, you will lose all the calibration. Your sensor will not be effective. So you lose the basically ability to function your payload properly. So that critical. So to build a propulsion system that reaches that maturity, you need a lot more groundworks before that. And that is what we have been doing for last 6-7 years. We have done one demonstration in space. Idea is how do we do that more number of demonstrations. So that is what sir has been guiding us, and we have been working on, and then get that confidence so that it becomes the de facto propulsion systems for the future satellite, and B, then build an infrastructure what Sakthi and we're discussing that can then we add one more layer of sustainability on top of it. So don't want to make a sustainability as a buzzword, because everyone wants to do that just for the heck of it, but at least it should have the genuine value to the ecosystem. Once that is there, then people will adopt naturally. That is the whole idea.
I agree with you. Not only that one, let us say the upper stages, small stages, whether ISRO is doing or anybody is doing, at least we should encourage, take risk, because ultimately scaling up is not that startup when they do the innovation and they find out one good profile, either hydrogen or hydrogen peroxide or water phase or anything. But we should take risk in implementing this one at least on a R&D basis for the upper stages. Okay, so that gives lot of confidence. That is actually the promotion what I feel, because if national space agencies with huge amount of capability on the research, if they don't let us say do, who else will do? It's not possible for a startup to put and qualify the green propulsion as a policy. Probably I think what you expect, that what support rather you expect from the launch vehicle service providers to qualify your green propellant.
Right. So just to answer your question, sir. So adding to exactly the point you were mentioning before. So we are working with one of the small launch vehicle company in France, and and especially in Europe, it is very sort of a strict mandate to have this kind of policy. So for their upper stage of launch vehicle, apart from the main engine which they are building, we are building our we are giving them a propulsion system which is green propulsion, basically safe to handle, and which will help them not just for final stage correction, but in the deorbiting of that stage. So because the government mandates are actually very strong, so they are making the provision beforehand. So the policies play the one important aspect, and government helps ensuring that you implement them, the cost, extra cost. So the government support helps in that side. So answering the second part of your question, sir, what are we expecting? So the flight heritage is the word for any component, any system for the space. And as much as flight heritage, not the one time, because one time it may work, but will it work will it work nth time is the question. So the target that we are setting up is that how can we quickly, at least 3, 4, 5 missions where we prove this system repeatability, reliability. If we can prove that, then that becomes a game changer. And that is what we are targeting with the satellites and then launch vehicle. If we can launch frequently from India, that will be the best. Otherwise, then we have to go outside and work with other foreign partners. Would love to do that within India.
I agree with you, because incidentally SSLV during the initial phases they not be possible. Probably for VTM, velocity trimming module, if we can use it, nothing like that. Okay, and going to Astroscale. Probably I think now the problem is the people are ready with guns and other things to mitigate. How to chase the target? How actually the technology you leverage, rather what kind of research is going on in Astroscale, especially in identifying the distances, whether it is LRF, laser range finders or laser instruments. Because recently I come across, one is if two satellites have to talk to each other, means both the things they should have some kind of consistency. Okay, with one only target, rather a chaser, without having target. What kind of challenges, what is the way forward to you? Can you please throw some light?
Thank you. I just realized it says that I'm
No,
from
we also
SES, but
realized
I'm
that,
from
yeah.
Astroscale. Sorry if I make someone disappointed. I'm from Astroscale, but thank you for the question, and thank you again for SIA for inviting me. And the difference of close approaches or RPO for International Space Station and what we did for space debris is there is no communication between servicer or chaser and the client, a target. So space debris, it's broken, so they don't do anything. They're just there. But for International Space Station, when like a Japanese HTV is docking, the two objects, International Space Station and HTV, can communicate each other. They can tell where they are located. So how we do make close approaches to space debris safely is we use two different navigation. One is absolute navigation, and the other one is relative navigation. I'm not an engineer, but try to explain it. But for absolute navigation, we use GPS and space situational awareness system to try to reach to the direction where the space object is located, debris is located. And once we see the figure of the object, we switch to the relative navigation using our own sensor, like LiDARs and other sensors, and make close approaches to 15 meters or 1.5 meters. So in order to do this, I think space situational awareness is very important. We are using like US, and of course US CSPOC. And Leo Labs, private companies, Leo Labs as well, and also SpaceNav is more for detailed planning of maneuvering and things like that. So that's how we use it. We use different kind of sensors according to different phases and try to make a safe trajectory and make a close approach to the target.
Thank you. You brought to another important things, cataloging and debris tracking. Digantara is doing an amazing job, especially in the lasers. Happy I would have been good if I had joined. Unfortunately, probably the organizers could not reach him out of their schedules. Fine. These are all the things I think most of the panelists talked about something. I'll just go back to Amer. The in the recent days, especially between India and UAE, lots of conversations are happening, especially in the space. I'm very happy. Some of the companies who are sitting in here, I don't want to take the name. They visited you. You have extended the thing. What is your rather? It could not be sustainability, probably, by the benefit of the Indian industries and other people. What kind of opportunities that you are throwing either for space missions, launching the satellites, services, including space situational awareness?
Yeah, I think
How you actually you expect rather invite the industries for creating opportunities, such kind of thing can you
I think first of all I have to thank SIA-INDIA because hosting these kind of events, brings us closer to each other. It brings the companies with us to discuss and have a dialogue. One platform we are launching every year, it's called Payload Hosting Initiative. It's a rather large CubeSat, around 12 U CubeSat. We can even expand it depending on the mission. We launch it every year, and on this platform we give through United Nations, UNUSA, opportunity to anybody from anywhere around the world to put new innovation and new concepts and new technologies on board the satellite. So we take care of the development, of the launch and the operation. And this way, as I think one of my colleagues here mentioned, you will have more time in space to verify your technology, longer hours in space. This will give you TRL 9 and beyond that. And this makes easy for you maybe sometimes to sell or to promote your product. So with every mission so far we have been launching, we have been putting a system that will be used for sustainability. Either it's a propulsion system or as I said, a parachute system to reduce or to increase the drag on a satellite. And we do this every year. So this is a big opportunity that I think will help everyone here. We can discuss that. Beyond that, we already have MBRSC is involved in a World Space Sustainability Association. It's WSSA. It's a major association in the UAE. It's headquartered in the UAE, but it's open for anybody around the world to join. It includes space agencies, it includes companies, businesses that are involved in space, and they have dialogue and discussion on a yearly basis on how to promote sustainability, find solutions with sustainability, and also involves different players, whether you're an agency or a regulatory entity, and also insurance companies. I mean, insurance companies have to be also involved in this because one of the regulations in the UAE that focuses on or at least supports sustainability is regulation on third-party liability and any collision that can or may happen in space, and that's kind of compulsory on any entity that wants to launch a satellite in the UAE. So these two initiatives I think will help bridge the gap between us and the audience here and maybe find opportunities.
Can I seek one clarification? Instead of you said payload opportunities, payload would be other than the bus, okay?
Yes.
Probably what I am saying, can I seek a kind of intervention? Probably not only the payloads, some of the subsystems.
Definitely.
Could be thrusters, could be your sensors, could be actuators, could be your OBCs, and because one thing is what we see such kind of open rather as a support, it helps many budding startups
Definitely.
to come join together and qualify this. That's what Tushar was telling. Flight worthiness, heritage is more important. One thing is when these guys come over there, your native technology landscape is getting scaled up.
Definitely.
Okay, so probably I think I also expect that not only payloads, subsystems
it's
also.
open to all. As I said, I mean, we are here to explore all kind of cooperation, as I said, and all the subsystems. But I just wanted to highlight the sustainability aspect of it. But as you said, and we noticed that always the startups, they always come with innovative ideas that are driving the future, and this is what we want to promote.
Thank you. I think huge Indian diaspora. When I was in Dubai for a month or so, many Indian startups came and they were projecting some technologies. Even Honorable Prince has come personally and pursued when something is not, because such a kind of vibrant leadership you have in UAE is amazing. You cannot compare such kind of things in any part of the world.
Well, I think maybe we are blessed with, as you said, the leadership that we have, and we have actually we have a young team also. So MBRSC, we are on average around 29 years old. I mean, the employees there. So we have a young team that wants to do and challenge
Yes,
big challenging missions in space, and but we believe it has to be done with international partners.
Thank you, thank you.
And India is very close to us, so
Yes, yes.
we want to cooperate.
Vineel, can you throw, see, let us say when you are making this kind of journey, because I could see still you are at TRL 4, 5 level, say to scale it up, what kind of support system, ecosystem that you expect, either from incubation angle or from, let us say, universities, technologies, mentorship, what kind of support, more support you expect? Be frank.
The more support I actually look into with the ISRO ecosystem itself. So we know that InSpace is there, and InSpace is supporting in a lot of ways where they are promoting few programs. But we require support directly from the industry to qualify some of the systems, and also have the facilities for very minimal cost, so that we can easily turn up our TRL levels from TRL 4 to higher level marks. And also when we have some conviction from the industry, or also from the government organizations, that we believe in your systems and we want to support your systems in order to scale it up, and there is a financial commitment as well, that would be easy for us to actually go up in the competition, and also have something say in the industry as well. And I believe that more and more sustainable activities in space should be there, and that is where every country is actually coming up with their own forms to have net zero orbits, like say Paris form, and also INSAM, and also Icarus projects. In the same way, I believe that India should also have its own sustainable consortium, where all the companies should come together, and we should actually promote few sustainable technologies that should be compulsory made with the government also. And you know that FAA guidelines says that now the 25-year deorbit rule should come back to 5-year deorbit rule. In the same way, if we actually promote more and more sustainable technologies to be very much stricter in sense, only then the orbital congestion will be lower. If you see the LEO orbit, if the same number of satellites, or the same track of satellites will be going on launch every year, the LEO orbit will be unsustainable by 2035 itself. Already 40% of the LEO orbit is already captured, and I think that instead of sending a satellite and putting it in orbit, and after its life just making it as a debris, if you reuse it and bring back to Earth, and again refurbish it, and again launch it, that would be a wonderful solution. That is where Taramandal is working on, wherein we are focusing on re-entry technologies and also reusable technologies as well.
Thank you, thank you. Sakthi, same question to you also, because what kind of, let's say, I'm sure InSpace is doing an amazing job, especially in supporting, probably in the propulsion front also, in the launch vehicle community is very busy with NGLV and Bharatiya Antariksha Station, which are capital intensive tests or something like that. Probably Jain is here, he is listening very coolly. The message is requesting InSpace to dedicate, to identify a dedicated slot like clusters, probably because it is all capital intensive. Would you also join me for some kind of, let's say, an exclusive support, because these are all futuristic technologies which are going to pick up after 5 or 6 years or 10 years down the line. If you establish your technologies today, India is going to become, why 45 billion? Yesterday I was telling, you put another zero on the right hand side. That is going as our target should be tomorrow redefined as 450 billion. Please.
Yeah, thank you, sir. Thanks once again, thanks, sir. Yeah, yes, actually, InSpace and ISRO, and definitely our government is actually supporting regarding the DISAM side very well. I was there last 2 weeks back at ESA, representing India and Orbitaid, where that explain about that zero debris charter and other on-orbit servicing, ISM things. And I was part of that conference committee and all those things, where we are also need that the same committee, ISM committees, ISM policy also has to come there. And when I came and explained to the in space and about the standardization, all those things, they said, yeah, okay, we are understood everything, so we can immediately take it to ISO. That's that's a immediate support we are getting it. So the conference actually done that, they announced it actually. Conference and AAA actually they announced to S1057. Then after that I explained to InSpace why we have to stop it at AAA, so we have to take it to ISO. So that is what that quick response is we are getting it. But one thing is actually what we are missing it whenever I'm going to Europe side or JAXA and other US side, especially the ISM committee, ISM policy regulation, it is we are very early stage. That is we have to come. That is has to come from InSpace side and ISO side. That is I'm requesting it. And other one is actually there is a multilateral program also regarding that. There is a lots of initiation regarding that multilateral Earth observation, agriculture, lots of things is initiated. But ISM also it is important. So that is we have to initiate. So that can be more. That will bring more sustainable. That is always. If I go and I approaching individually as an Orbitaid, they'll immediately ask. Actually, we have to come through committee. We have to come through the governments. That is what I'm hearing feedback from ESA and NASA also in the conference.
Thank you, Shakti. Tushar, one specific question to you. Today, whatever the satellite fuel that you are developing, there is only 1 kg, 2 kg, maximum 10 kg, and the productivity is very low. Let us say anticipating that yes, green propellant is going to be decided soon. Tons of fuel production is required. So what kind of readiness, industry readiness that you expect? Because today for semi-cryo ISRO is required, we have done it, and LH2 is required, LOX is required, similarly A204, huge capacity is required. Where do you say the industry, because even though technology wise you are ready with the technology, but if the fuel and if the things not there is of no use. So what you expect from the ecosystem, what kind of futuristic actions that you need to establish the industry for managing such kind of huge demands?
No, definitely, and in fact, sir, what you are mentioning, we are facing the problem as we speak, and we are trying to find out the solution. And do we make in-house in India, set up the facility of our own? Do we work with ISRO? ISRO has some facilities, especially the hydrogen peroxide side. Do we import from outside, which is very costly, time-consuming, and import has a big challenges. So we are struggling with it. Solution, we are trying to find out what is the best in terms of that requirement at that time as well as the cost-wise. But if as an industry, if we can scale it up together, so people, because currently they don't see the scale immediately, so they are not willing to invest. But we see that there is a scale tomorrow. Challenge is that they're saying they want commitment from us that we may not be able to do it immediately. So the idea is that how do we bridge that gap, MOQ versus low volume, that gap, yes. So that is what we are trying to bridge it with definitely in-house efforts at Manastu. Indian partners, if not, then we need to go for a global partner. So definitely ISRO also has some capability in it, but not definitely that will cater to say maybe next 2, 3, 5 years in say ton kind of requirement.
I agree with you. Scale lab level, you have developed something that has to be scaled up. Hopefully, the larger industries and corporates, they'll have an eye on this one. I respectfully give a more publicity and demand in the higher forums to air such kind of opinions so that somewhere it will click. I think in a limited time, you want to add something, please.
I'll add small things. It's actually, yes, it's a nice question regarding that fuel requirement and all those things. Where the sustainable and life extension and refueling, so that supply chain has to be maintained properly. That supply chain maintenance has to be, that is what Tushar is mentioning clearly. This in-house things and ISO things has to be, but the supply chain availability is important, then we have to do that extension immediately.
No, not only supply, decontamination.
Yeah, decontamination, of course.
Recycling, reusability, containerization, transportation, storage, whatnot. It's only lab level 1 kg, 10 kg handling is not the issue. When you go to 10 tons, 100 tons with a huge demand, I think that these are all the concerns. Probably in a limited time, probably I think organizers are looking at me to close. Already 2 minutes are overshot. I think the panel has come out with a good kind of overview. Probably the sustainability only leads us, gives us. Today we may take breathing, but continuous breathing is only out of these measures. Let us hope that the government policies and the agencies who are responsible, the entire ecosystem will take note of all these policies and embed the requirements in a befitting way in terms of requirements to the agencies. All. Let us hope that we will have a very safe, sustainable space ecosystem in the future days to come. Thank you again, once again. I thank all the panelists. Thank you.
I would like to take a moment to invite the winner of SIA-INDIA's Call for Paper initiative, Mr. Vinay Kumar Reddy, to present his paper amongst our esteemed dignitaries.
Good afternoon, everyone. This is Vinay Reddy from Relisat. So the panel over here has discussed most of the topics regarding the space sustainability. So they have included the reusability and refueling along with the active debris removal as well. I guess my paper would complete this panel. So here, most of the solutions which they have given are for active systems. My paper is completely based on passive systems. So here my paper title is Drag Sails for Passive Satellite Deorbiting. So here the paper consists of a sustainable and economical approach for the debris removal. So the drag sails which I'm talking about, so the CubeSats, when we are discussing about 1U, 2U or 3U, 6U and 12U, so on satellites, so most of the time they do face volumetric constraints, cost and mass constraints. So for that kind of systems, what are the kind of deorbiting systems which we can use? So what if there is not enough volume for housing the propulsion system, like electric propulsion system as such? So what is the other alternative which we can go for? And being capable of following the policies which are set by the government organizations by reducing the deorbiting lifetime of the satellites from earlier 25 years, and right now increasingly the organizations are implementing 5 years deorbiting time after the end of the lifetime missions. So these are the existing deorbiting strategies which are there: chemical propulsion, electrodynamic tethers, and ADR and atmospheric drag. So the current system which I'm talking about, the drag sails, here the concept is very simple. When we look at the drag equation, so force of drag is directly proportional to the surface area. So as the surface area increases, over there the drag force increases. So when the satellite is in various orbits, like if we consider a 300 kilometers orbit and we have a 1U satellite in that particular orbit, then the surface area, if we take 0.01 meter square, then the amount of drag which is acting on that is significantly lesser than if we have a drag sail on that, the drag sail having a surface area of 1 meter square and the drag acting on 1 meter square is significantly higher. So in this particular paper, I have analyzed how implementation of drag sails would reduce the deorbiting time gradually from the orbits from 300 kilometers orbit all the way to the 1000 kilometers orbit. And uses of drag sails, so it is compatible with all the CubeSat form factors. So here the design approach is in such a way that we are not going to occupy the volume of the CubeSat, but rather we are going to occupy the tuna can volume, which is outside of the CubeSat, so that the existing volume is used completely by the payload and electronics, but the deorbiting system would use the tuna can volume. And yeah, it does not require any propellant as such. And the power requirement for this is as well quite minimal. It is only required to initiate the deployment. So if you ask me, did any of the past missions have utilized the drag sails? Yes. So the first one was NanoSail D2, which was by NASA, and later on by Tech Demosat from UK, X7 from Canada, Spinnaker from Purdue University, and currently there are two companies which are actively working on developing these drag sails as a product. So that is HPS GmbH, which is in Germany. The system name is Adios Neo 2. And currently in Transporter 14, there are two satellites which have been launched, Relisat and TPA-1, which is from Australia and New Zealand. They both have utilized a drag sail as their deorbiting system. So these are the images of that. And you can see at the bottom the Relisat, at the top the number 1 Mark 1 is the drag sail, which they are using to deorbit the satellite. And if you see the Spinnaker 3, so this is something which we want to test in the orbit. So there is an upcoming SMILE mission which InSpace is planning. So we are planning to test something like that on the SMILE mission. So the Draxel, we are planning to test that. And when it comes to the analysis which I have done, so these are the parameters which I have considered to do the analysis. And this is the results which we have got from that. So without the sail, the deorbiting time is quite getting higher as we move to the upper altitude. Here the satellite which we have considered as was 1U satellite with, if there is a drag sail, considering that axle is 1 meter square drag sail. And I have done the analysis with two different ways. So the blue line represents only the effects of drag, but green line represents the effects of drag and also SRP. So from this analysis, what I have understood is that the effects of drag is quite significant at an altitude less than 500 kilometers. But later, as we move on to the higher altitudes, the effects of drag are less, but we can utilize the effects of solar radiation pressure. So with that, we can significantly reduce the deorbiting time of the satellite. So these are the values which I got from that. And yeah, from the observations. So from this we have understood that as the mission, if the mission of the satellite is over 500 kilometers, then the surface area of the sail also needs to be included, and it has to be customized basically based on the satellite mass and the size requirements and also the altitude requirements. And when, as the paper title says, economical approach. So if we compare the cost, mass and volumetric impact of the drag sail with other systems, electric propulsion and coal gas thrusters, so it is quite significantly less costlier. In my paper, I have detailedly listed out the breakdown of the cost for the drag sail. And even the mass as well is significantly lesser, and the volume over there it's given 0.5U, but later on the design has been changed and we have moved to the tuna can value. And the power requirement is as well very low. And this is the system, the prototype one, I would say, which have developed recently. So it is in the form of a tuna can. It can be attached at the bottom of the CubeSat, and once it is deployed. So yeah, this is a small video, sorry for my informal attire. So this shows the deployment of the site. Yeah. So this can be deployed at the end of the satellite lifetime, and from there the drag and the solar radiation pressure will do their work and deorbit the satellite. Yes, that's it. That's my work. Thank you.
Before we end this session, I would like to take a moment to extend my heartfelt gratitude to all the dignitaries on the dais. Thank you for gracing us with your presence, for sharing your insights, for making this session truly enriching. Your valuable contribution have added great meaning to today's gathering. We are truly honored to have you with us. As a token of gratitude and appreciation, we now present mementos to our eminent panelists. May I now request Mr. Sudheer Kumar to present memento to Ms. Aya. To Mr. Tushar. To Mr. Sakthi. To Mr. Vineel. and to Mr. Amer. May I now request Mr. Rajit Ali, Senior Advisor, SIA-INDIA, to present memento to the chair. I would like everyone to come forward for the group photo. With this, we come to the end of today's session. On behalf of the entire organization team, I extend my sincere thanks to all our speakers, dignitaries, and each one of you in the audience for the active participation and presence throughout the day. We look forward to welcoming you all again tomorrow for another fulfilling day. Please join us sharply at 8. Thank you once again and have a wonderful evening.